The universe is vast and mysterious. We look out at the stars and galaxies and we wonder what is real. Could it be that everything we see is just an illusion? Philosophers and scientists have pondered this question for centuries. Is there something more beyond our perception? The answer might lie in the very fabric of the cosmos. Our senses tell us one story, but the universe holds many secrets. What we perceive as solid and real is, at a fundamental level, made up of particles in constant motion. These particles are governed by laws that seem strange and counterintuitive to our everyday experience. To understand the universe, we must be willing to question our assumptions and embrace the unknown. This journey begins with a simple question: what is the true nature of reality? As we delve deeper into the cosmos, we'll encounter mind-bending concepts that challenge our understanding of the universe. Prepare to have your mind expanded and your perception of reality forever altered. When we look up at the night sky, we are seeing light that has traveled vast distances to reach us. Some of this light comes from stars millions of light years away, meaning it has taken millions of years to reach our eyes. This means we are seeing these stars as they were millions of years in the past. We are looking back in time. The observable universe is everything we can see from Earth, limited by the speed of light. The universe is around 13.8 billion years old, so we can only see objects that are within 13.8 billion light-years of us. This is just a tiny fraction of the entire universe, which is likely infinite in size. Beyond the observable universe, there may be countless stars, galaxies, and even other forms of matter and energy that we cannot detect. This is because the light from these objects has not had enough time to reach us since the Big Bang. It is a humbling thought to realize how much of the universe remains hidden from our view. To understand the relationship between time and distance in the universe, imagine a space-time diagram. This diagram represents space on one axis and time on the other. Light travels in a straight line on this diagram at a constant speed. As we look at objects further away from us, we are looking further back in time. Imagine a star that is 1 million light-years away. We see it today as it was 1 million years ago, when the light we are now seeing left the star. The further away an object is, the further back in time we are looking. This concept has profound implications for our understanding of the universe. It means that the universe is not a static picture, but rather a dynamic, ever-changing entity. When we observe distant galaxies, we are witnessing their evolution over billions of years. Albert Einstein's theory of relativity revolutionized our understanding of space and time. He showed that time is not absolute, but relative to the observer. Time passes differently for objects moving at different speeds or experiencing different gravitational fields. Imagine two clocks, one on Earth and one on a spaceship traveling at high speed. According to relativity, the clock on the spaceship will tick slower than the clock on Earth. This is not an illusion. Time itself is passing slower on the spaceship. This effect, known as time dilation, has been experimentally verified. It has profound implications for our understanding of the universe, and it challenges our everyday intuition about the nature of time itself. Section 5: The Quantum Puzzle. Quantum mechanics is a branch of physics that studies the behavior of matter at the atomic and subatomic level. It reveals a strange and counterintuitive world where particles can exist in multiple states at once, and where the act of observation can influence the outcome of an experiment. One of the most bizarre implications of quantum mechanics is the idea that reality might be a simulation. This idea, known as the simulation hypothesis, proposes that our universe could be a computer program running on a super-advanced computer. While this may seem like science fiction, some physicists believe it is a serious possibility. They point to the fact that the universe appears to be governed by mathematical laws, which could be seen as evidence of a simulated reality. Section 6: Reality as a hologram. The holographic principle is a mind-bending idea that suggests our three-dimensional reality could be an illusion. It proposes that the information about everything in our universe could be encoded on a two-dimensional surface like a hologram. This surface would exist at the boundary of the universe, and everything we see and experience would be a projection from this surface. Imagine a hologram you might find on a credit card. It appears to be a three-dimensional image, but it is actually encoded on a two-dimensional surface. The holographic principle suggests that the entire universe could work in a similar way. While this idea is still speculative, it has garnered attention from physicists as a potential way to reconcile quantum mechanics and general relativity. It challenges our fundamental understanding of the nature of reality and raises profound questions about the universe we inhabit. Section 7. The universe in the mind. Our brains are constantly bombarded with sensory information which they interpret to create our perception of reality. But what if this perception is flawed? What if our brains are filtering or distorting the information they receive, shaping our experience of the universe? Some neuroscientists believe that our perception of reality is a kind of controlled hallucination. Our brains construct a model of the world based on incomplete information, and this model is what we experience as reality. This raises the possibility that the universe we experience is not the objective universe but rather a subjective construct created by our own minds. It suggests that the nature of reality may be even stranger and more wonderful than we can imagine. Section 8. The joy of discovery. Despite the mind-boggling implications of these ideas, there is a certain beauty and wonder in contemplating the nature of reality. The universe is full of mysteries, and unraveling them is one of the greatest joys of being human. Whether or not our universe is an illusion, the very act of questioning our reality is a testament to the power of the human mind. We are curious creatures, driven by a deep desire to understand the world around us. The journey of scientific discovery is an ongoing one, and there is still much we do not know. But with each new discovery, we gain a deeper appreciation for the vastness and complexity of the cosmos. Section 9. An everlasting mystery. In the end, the question of whether or not the universe is an illusion may be unanswerable. But perhaps that is part of what makes the universe so captivating. It is a place of endless wonder, where the only limits are those of our own imagination. As we continue to explore the cosmos, we should embrace the unknown with a sense of awe and humility. The universe is a vast and mysterious place, and we are privileged to be a part of it. Let us never lose our sense of wonder, for it is in the face of the unknown that we truly discover the beauty and majesty of the universe. Gap 3S Section 10. The Multiverse Hypothesis. Gap 1S. As we ponder the nature of reality, one of the most intriguing and mind-bending concepts to emerge is that of the multiverse. The idea that our universe may be just one of countless others, each with its own unique laws of physics and properties, is both thrilling and perplexing. The multiverse theory is not just the realm of science fiction, it has its roots in various scientific theories and speculative ideas. One such theory is cosmic inflation, proposed by physicist Alan Guth. According to this theory, during the very early moments of the Big Bang, the universe underwent an exponential expansion. This rapid inflation could have caused bubbles of space-time to form, each developing into its own separate universe. Another compelling idea comes from quantum mechanics and the many worlds interpretation, formulated by Hugh Everett. This interpretation suggests that every quantum event spawns a branching of universes, each representing a different possible outcome. In this view, every decision we make, every roll of the dice, creates a new universe where a different path is taken. Moreover, string theory, which attempts to reconcile general relativity and quantum mechanics, also hints at the existence of multiple universes. In this framework, our universe might be one of many brains floating in a higher dimensional space. These brains could occasionally interact, potentially giving rise to observable phenomena. While these theories are still speculative and face significant challenges, they expand our understanding of what reality could be. Could there be other universes where the constants of nature are different, where life evolves in unimaginable ways, or where the very concept of time is altered? The multiverse hypothesis pushes the boundaries of our curiosity and imagination. It invites us to consider the profound possibility that our reality is just one of an infinite tapestry of realities. In contemplating the multiverse, we are reminded of the boundless creativity of nature and the endless quest for knowledge that defines us as a species. As we delve deeper into these mysteries, let us remain open to the wonders that lie beyond our current understanding. For in the vast expanse of potential universes, the journey of discovery is infinite, and the nature of reality continues to beckon us with its enigmatic allure. As we navigate the vast possibilities of the multiverse, we are brought back to a fundamental question: what role does consciousness play in shaping our perception of the universe? This question bridges the domains of neuroscience and philosophy, offering a profound exploration into the nature of reality. From a neuroscientific perspective, consciousness is the result of complex interactions within the brain. Neurons communicate through electrical and chemical signals, creating a network of activity that gives rise to thoughts, emotions, and our sense of self. Researchers like Christoph Koch and Giulio Tononi have proposed theories such as integrated information theory, which attempts to quantify consciousness and explain how it emerges from neural processes. Yet despite these advances, the hard problem of consciousness, as coined by philosopher David Chalmers, remains elusive. How does subjective experience arise from physical processes? This question challenges our understanding of reality at its core. Philosophers have long pondered the nature of consciousness and its relationship to the universe. René Descartes famously declared, "I think, therefore I am," emphasizing the centrality of the thinking self in our experience of reality. More contemporary thinkers like Thomas Nagel have argued that there is something it is like to be a conscious being, a perspective that cannot be fully captured by objective science. The interplay between consciousness and the universe is not just an abstract debate, it has practical implications for how we experience the world. Our perceptions are filtered through the lens of our conscious mind, influenced by our thoughts, emotions, and memories. This subjective reality shapes our understanding of the universe, making each individual's experience unique. Some theories even suggest that consciousness could play a fundamental role in the fabric of reality itself. The participatory universe theory, proposed by physicist John Archibald Wheeler, posits that observers are necessary to bring the universe into being. In this view, consciousness is not just a passive observer but an active participant in the creation of reality. As we explore the mysteries of consciousness, we are reminded of the profound interconnectedness of mind and universe. The quest to understand consciousness is not just a scientific endeavor but a deeply human one, touching on the very essence of what it means to exist. In contemplating the role of consciousness, we open ourselves to new ways of understanding reality, bridging the gap between the external universe and our internal experience. This journey invites us to reflect on our place in the cosmos, and the infinite possibilities that lie within and beyond our minds. As we conclude our exploration, let us carry forward the spirit of curiosity and wonder, embracing the mysteries of consciousness and the universe. For in the dance between mind and cosmos, we find the essence of our quest for knowledge and the boundless potential of human discovery. As we venture deeper into the mysteries of existence, we encounter a provocative and mind-bending theory, the simulation hypothesis. Could it be that our universe is not the fundamental reality but rather a sophisticated computer simulation? The idea that our reality might be simulated is not new. Philosophers like René Descartes pondered the nature of existence and reality centuries ago. However, in modern times, this theory has taken on a new dimension with the advent of advanced technology and computer science. Pioneers like Nick Bostrom have argued that, given the rapid pace of technological advancement, it is conceivable that future civilizations could create simulations so intricate that the beings within them would be unaware of their artificial nature. Proponents of the simulation hypothesis point to several compelling arguments. Firstly, the exponential growth in computing power suggests that it could eventually become possible to simulate entire universes. If this is the case, it stands to reason that there could be many more simulated realities than base realities. Therefore, it becomes statistically probable that we are living in one of these simulations. Secondly, the peculiarities of quantum mechanics, such as the observer effect and quantum entanglement, have led some to speculate that these phenomena could be indicative of underlying computational processes. The resolution of these quantum puzzles might lie not in the fabric of the universe itself, but in the algorithms running the simulation. However, there are also strong arguments against the simulation hypothesis. Critics argue that the sheer complexity of simulating an entire universe down to the quantum level would require an unimaginable amount of computational resources. Even with future advancements, creating such a simulation might be beyond the realm of possibility. Furthermore, the hypothesis raises significant philosophical and ethical concerns. If we are indeed living in a simulation, what does that mean for our sense of purpose and morality? Are our lives less meaningful if they are the product of artificial constructs? These questions challenge our understanding of existence and the value we place on human experience. Despite the tantalizing possibilities, there is currently no empirical evidence to support the simulation hypothesis. It remains a theoretical construct, a thought experiment that pushes the boundaries of our imagination and scientific inquiry. As we grapple with the notion of simulated realities, we are reminded of the profound mysteries that surround us. Whether or not we are living in a simulation, the quest to understand our universe continues to inspire awe and wonder. Each new theory, each new discovery brings us closer to the truth, even as it opens up new questions and possibilities. In the end, the simulation hypothesis invites us to reflect on the nature of reality itself. It challenges us to consider the limits of our knowledge and the boundless potential of human curiosity. And in this pursuit, we find the true essence of our quest for understanding. As we conclude this exploration of simulated realities, let us embrace the mysteries that lie before us, ever eager to uncover the secrets of the universe, whether they be real or simulated. As we journey through the depths of the cosmos, we encounter an enigma that has puzzled scientists for decades: the mysteries of dark matter and dark energy. These elusive components make up the vast majority of our universe, yet their true nature remains shrouded in uncertainty. Dark matter, though invisible, exerts a gravitational pull that affects the motion of galaxies and galaxy clusters. It acts as the scaffolding upon which the visible universe is built. Despite its critical role, dark matter does not interact with light or electromagnetic forces, making it incredibly difficult to detect. Scientists rely on indirect evidence, such as the gravitational effects on visible matter, to infer its presence. On the other hand, dark energy is even more perplexing. It is believed to be responsible for the accelerated expansion of the universe. Unlike dark matter, which clumps together, dark energy is thought to be uniformly distributed throughout space, exerting a repulsive force that counteracts gravity. This mysterious force was first observed through the study of distant supernovae, which revealed that the universe's expansion is speeding up, not slowing down as previously thought. The discovery of dark energy has profound implications for our understanding of the cosmos. It challenges the long-held assumption that gravity would eventually halt the expansion of the universe and cause it to collapse in a big crunch. Instead, dark energy suggests a future where the universe continues to expand indefinitely, leading to a cold, dark, and isolated cosmos. Despite the progress made in understanding these dark components, many questions remain. What exactly is dark matter? Is it composed of undiscovered particles? Or could it be a manifestation of new physics beyond the standard model? And what is the true nature of dark energy? Is it a cosmological constant as proposed by Einstein, or something more dynamic and variable? The pursuit of answers to these questions drives the cutting-edge research in cosmology and particle physics. Experiments like the Large Hadron Collider and observatories like the Vera C. Rubin Observatory are designed to probe the nature of dark matter and dark energy, pushing the boundaries of our knowledge. As we delve into the dark frontier, we are reminded of the vastness of our ignorance and the boundless potential for discovery. The mysteries of dark matter and dark energy serve as a testament to the complexity and wonder of the universe, challenging us to look deeper and think beyond the known. In this quest for understanding, we find not just the answers to our questions, but a deeper appreciation for the intricate tapestry of the cosmos. Each discovery, each breakthrough brings us closer to unraveling the secrets of the universe, illuminating the darkness with the light of human curiosity and intellect. As we stand on the brink of new revelations, let us embrace the unknown, driven by the joy of discovery and the enduring quest for knowledge. The dark frontier awaits, and with it, the promise of uncovering the profound mysteries that shape our existence. As we venture beyond the dark frontier, we are drawn to another profound mystery that has captivated human imagination for centuries: the enigma of time. What is time, and how does it shape our understanding of reality? These questions have inspired countless theories, from ancient philosophies to cutting-edge scientific research. Time, as we experience it, seems to flow inexorably from the past to the present and into the future. Yet this linear progression is an illusion, a construct of human perception. In the realm of physics, particularly in Einstein's theory of relativity, time is intertwined with space, forming a four-dimensional continuum known as space-time. This revolutionary concept challenged the traditional notion of time as a separate, absolute entity. Einstein's theories revealed that time is relative. It can stretch and contract depending on the observer's velocity in the presence of massive objects. This phenomenon, known as time dilation, has been confirmed through numerous experiments, such as observing the decay rates of particles traveling at near-light speeds, and the precise measurements of atomic clocks on fast-moving aircraft. The implications of relativity open the door to the tantalizing possibility of time travel. If time can be stretched and bent, could we manipulate it to journey into the past or future? Theoretical physicists have proposed various mechanisms such as wormholes, hypothetical tunnels through space-time that could connect distant points in time and space. While these ideas remain speculative, they push the boundaries of our imagination and understanding. However, the nature of time itself remains a profound mystery. Is time a fundamental aspect of the universe, or is it an emergent property arising from deeper, more fundamental processes? Quantum mechanics, the framework governing the behavior of particles at the smallest scales, introduces further complexity. The famous arrow of time puzzle arises from the apparent contradiction between the time-symmetric laws of quantum mechanics and the irreversible flow of time we observe in daily life. Moreover, the concept of entropy, a measure of disorder in a system, plays a crucial role in our perception of time. According to the second law of thermodynamics, entropy tends to increase in an isolated system, giving rise to the arrow of time. This increase in entropy aligns with our experience of time's passage, as events unfold from order to disorder. Yet, this explanation leaves open questions about the initial low-entropy state of the universe and the ultimate fate of time. As we delve deeper into the temporal enigma, we encounter philosophical questions that challenge our understanding of existence. If time is not an absolute, immutable backdrop, what does it mean for our concepts of causality, free will, and the nature of reality itself? Could our perception of time be a mere cognitive construct, shaped by the limitations of our minds? In our quest to unravel the mysteries of time, we find ourselves at the intersection of science and philosophy, exploring the fundamental nature of reality. Each discovery, each theoretical breakthrough, brings us closer to answering these profound questions, illuminating the intricate tapestry of the cosmos and our place within it. As we stand on the brink of new revelations, let us embrace the unknown, driven by the joy of discovery and the enduring quest for knowledge. The temporal enigma awaits, offering the promise of uncovering the profound mysteries that shape our existence. As we continue our journey through the cosmos, we turn our attention to the groundbreaking discoveries in astrophysics that have fundamentally altered our perception of the universe. These recent breakthroughs, such as the detection of gravitational waves and the first-ever imaging of a black hole, have opened new windows into the fabric of reality. Gravitational waves, ripples in space-time caused by cataclysmic events like the collision of black holes, were first predicted by Albert Einstein over a century ago. However, it wasn't until 2015 that the Laser Interferometer Gravitational Wave Observatory, or LIGO, made the historic detection. This monumental achievement confirmed a key prediction of Einstein's theory of general relativity and provided a new way to observe the universe. Gravitational waves offer a unique glimpse into the most violent and energetic processes in the cosmos, allowing us to study phenomena that were previously beyond our reach. The first direct image of a black hole, captured by the Event Horizon Telescope in 2019, marked another milestone in our understanding of these enigmatic objects. The image revealed the shadow of the supermassive black hole at the center of the galaxy M87, surrounded by a glowing ring of hot gas. This observation not only provided visual confirmation of black holes but also offered insights into their behavior and the extreme conditions near their event horizons. These discoveries have profound implications for our understanding of the universe. They challenge our notions of space and time, pushing the boundaries of our knowledge and inspiring new theories. The detection of gravitational waves has opened a new era of multi-messenger astronomy, where we can observe cosmic events through both electromagnetic radiation and gravitational waves. This complementary approach promises to unlock deeper insights into the workings of the universe. Moreover, these breakthroughs highlight the importance of international collaboration and the power of advanced technology in expanding our horizons. The success of projects like LIGO and the Event Horizon Telescope is a testament to the ingenuity and perseverance of scientists around the world. As we reflect on these astrophysical revelations, we are reminded of the ever-evolving nature of our understanding. Each discovery brings us closer to unraveling the mysteries of the cosmos, yet also reveals new questions and challenges. The universe is a vast and dynamic tapestry, and our quest to comprehend it is an ongoing adventure. In the face of these profound discoveries, we are filled with a sense of wonder and curiosity. The cosmos beckons us to explore its depths, to seek answers to the fundamental questions of existence. Let us embrace this journey with open minds and hearts, driven by the joy of discovery and the unending pursuit of knowledge. The universe awaits, offering the promise of new revelations and the thrill of uncovering the secrets that lie beyond the stars. As we stand on the precipice of our astrophysical revelations, we are compelled to reflect on the profound philosophical implications of a potentially infinite universe. The concept of infinity stretches the very limits of our imagination, challenging our understanding of existence and our place within the cosmos. An infinite universe suggests that the cosmos has no boundaries, no edges, and no end. It implies that there are endless possibilities, countless worlds, and perhaps even infinite versions of ourselves. This idea forces us to reconsider the uniqueness of our existence. Are we but one of many iterations, living out countless variations of our lives in parallel realities? The notion of infinity also touches on the concept of time. If the universe is infinite, then time too may have no beginning or end. This challenges the linear perception of time that governs our daily lives, and invites us to contemplate the cyclical and eternal nature of existence. In an infinite universe, every moment, every event, and every action may be part of an endless loop, repeating across the vast expanse of space and time. Moreover, the idea of an infinite universe raises questions about the very nature of reality. If the cosmos is boundless, then our understanding of what is real becomes fluid and ever-changing. The boundaries between the possible and the impossible blur, and we are left to ponder the true nature of our existence. Are we mere specks in an unfathomable expanse, or are we integral parts of a grand, interconnected tapestry that transcends our limited perceptions? This contemplation of infinity also brings a sense of humility. In the face of an infinite cosmos, our individual lives may seem insignificant, yet at the same time, this vastness can inspire a profound sense of connection. We are part of something much greater than ourselves, woven into the fabric of an endless universe. This realization can foster a sense of unity, reminding us that we share this cosmic journey with all of existence. As we navigate these philosophical waters, we are reminded of the importance of curiosity and wonder. The infinite universe beckons us to explore, to question, and to seek understanding. It invites us to embrace the unknown and to find meaning in the journey itself. In the end, the concept of an infinite universe is both a challenge and an inspiration. It pushes the boundaries of our knowledge and compels us to rethink our place in the cosmos. It reminds us that the quest for understanding is a never-ending adventure, filled with awe, mystery, and the promise of discovery. The infinite universe is a testament to the boundless potential of human curiosity and the enduring spirit of exploration. As we continue to unravel the mysteries of the cosmos, let us carry with us the wonder and humility that come from contemplating the infinite. For in the face of eternity, we find both our greatest questions and our deepest sense of connection. The universe, infinite and eternal, awaits our exploration. Let us venture forth with open minds and hearts, driven by the timeless pursuit of knowledge and the joy of discovery. Throughout this video, we have delved into the profound mysteries that shape our understanding of reality and the universe. We began by questioning if reality itself is an illusion, exploring the limits of our vision and the echoes of the past. Einstein's revolutionary theories and the perplexing nature of quantum mechanics open new vistas of understanding, leading us to consider the universe as a potential hologram. We pondered the universe within the mind and celebrated the joy of discovery, only to be reminded that these mysteries are everlasting. The multiverse hypothesis and the consciousness conundrum pushed our boundaries even further, leading us to contemplate the simulation hypothesis, the dark frontier, and the enigma of time. Our journey through astrophysical revelations brought us to the concept of an infinite universe, challenging our notions of existence, time, and reality itself. As we stand at the precipice of these cosmic mysteries, we are reminded that our understanding of reality and the universe is both a challenge and an inspiration. The infinite universe beckons us to explore, to question, and to seek understanding. It invites us to embrace the unknown and to find meaning in the journey itself. In conclusion, the nature of reality and the universe is a testament to the boundless potential of human curiosity and the enduring spirit of exploration. As we continue to unravel the mysteries of the cosmos, let us carry with us the wonder and humility that come from contemplating the infinite. For in the face of eternity, we find both our greatest questions and our deepest sense of connection. The universe, infinite and eternal, awaits our exploration. Let us venture forth with open minds and hearts, driven by the timeless pursuit of knowledge and the joy of discovery. You're watching Astro Vibe, where we explore the universe, from the depths of the oceans to the edges of the cosmos. If you enjoyed this journey, give it a like, share with fellow explorers, and subscribe to stay tuned for more wonders of our planet and beyond. Until next time, keep your curiosity alive.